Hi grade 11s, welcome to today's session. My name is Hayley and I'm going to be taking you through probability. Right, let's see what we're doing today. Our key concepts for today. Right, without realizing it, you actually make use of probability just about every day. We say that there's a chance that it might rain today. It'll probably go out for supper tonight. So we're always using probability and we're not even realizing it. Probability can be expressed in 3 different ways. We talk about a common fraction, kind of 1 out of 2, a decimal fraction, which will be 0,5, and a percentage of something happening, say 50%. It's really important to remember that however this probability is expressed, the smallest value is always 0, there is no chance of it happening, and the biggest value is always 1. There's a 100% chance of it happening. So we always base everything between 0 and 1, or if you'd like to use it as a percentage, between 0% and 100%. So it either can't happen at all, or there's a 100% chance that it will definitely happen. Right, let's go through how we do the calculations on probability. When doing probability calculations, all the possible ways in which the calculations could be worked out are called the outcomes. So that is every single possible outcome, every single possible way that it can occur is called an outcome. The specific outcome that you're looking for is called an event. So we are always looking for one event that occurs out of our total possible outcomes. And that's why our formula is the probability is equal to the number of ways that the event can occur, the number of ways that that event can occur out of the total number of possible outcomes. So what's important for us today is to actually work out that total possible number of outcomes, and then we can work out the probability of a single event occurring. Let's look at an example. In a box of pencils, in a box of pencils, there are 5 yellow pencils, 3 green, 5 blue, and 7 red. Now we want to calculate the probability that you will pick a yellow pencil. So I need my possible events, my events where I have picked a yellow. So I'm going to look at my yellow. I'm going to say my probability is equal to, well, there are 5 yellow pencils, so I can pick out 5, and that is my event. Out of the total possible outcomes, the total outcomes is how many pencils do we actually have. So we add them up, 5 and 3 and 5 and 7, right, that adds up to 20 pencils. So my probability is 5 out of 20. Now, unless the question tells you otherwise, you can leave it as a fraction like that. You don't have to simplify it, and you don't have to write it as a percentage or as a decimal. You can leave it like that. So if I use my calculator and I use my fraction button and I pull in 5 over 20, as soon as I press equal on your calculator, it's going to simplify the solution. And that is fine. So you can actually write in that simplified solution, which is equal to 1 out of 4. But you don't have to round off, and you don't have to simplify. Right, let's go on to the next one. Let's just extend the page a little bit. I'm looking for a yellow or red pencil. Now, when we see or in probability, we need to add. So what I'm going to do is I'm going to find out the probability of picking a yellow pencil, the probability of picking a red pencil, and I'm going to add them together. I'm going to show you, I'm going to do it mathematically, then I'm going to show you how you would do it without realizing that it was a plus. So my yellow pencil, I had 5 yellow pencils. So I've already calculated that was 5 out of 20. My red pencils, well, I've got 7 of those. So that is 7 out of 20. And if I add those together, and you can use your calculator to do this, but I think we can quite easily add these together, so we end up with 12 out of 20. Now, just in case you've forgotten that OR is add, let's just go through the question again, and I'm looking for a yellow or red pencil. So I'm going to just delete those, and let's use a different color. So I've got 5 yellow pencils, and I've got 7 red pencils. So in total, out of all the pencils that I've got, there are actually 12 that would fit my event, my criteria, and out of the total possible 20 pencils. So you can see that we ended up with the same answer as we did with the calculations with the OR. Right, let's now discuss the different ways we can calculate the number of outcomes. The first thing we can do is use a tree diagram. A tree diagram is a visual representation of all the possible outcomes. Each branch of the tree provides all the possible outcomes for that particular event. And what's important to remember that for every branch, you need to continue your tree. And we're going to go through an example where I'll discuss it with you. So, when you get dressed in the morning, you have the following options. You've got 2 pairs of pants. You can either wear black pants or jeans. You've got 3 different types of shirts. You can wear a white shirt, a blue shirt, or a green shirt. And finally, you've got 2 pairs of shoes that you can use. We've got tackies or sandals. Now, if you had to be getting dressed in the dark and you were just randomly selecting clothes, this is what we're looking for as the outcome. So we're going to draw a tree diagram to look at each event. So the first thing we're going to do is we're going to start with the pants. So for our pants, if you remember correctly, we had 2 choices. We can either wear black pants or jeans. So I've already actually drawn this in. We've got black pants or jeans. 2 parts of the tree, 2 branches. Then we're going to look at the next event. So our next event is the shirts. Whether we're going to choose, and whether we choose black pants or the jeans, we still have 3 choices of the shirt. So what I want you to do is for every branch, now our black is 1 branch, we're going to now have a white shirt, a blue shirt, or a green shirt. That's how we draw the tree diagram. And if I had chosen my jeans, I can still wear a white shirt, blue shirt, or a green shirt. So this is what I mean about including every single branch we actually need to fill in the outcomes. So this was our pants, and this is our shirt. Now let's go on and see what happens when we add the shoes. So for every branch, I'm going to add the type of shoes that I've got. So I could have had my black pants, white shirt, sandals, or tackies. And for each branch, I add my sandals or tackies. Then we can count the number of different outcomes. So each one of these is actually an outcome. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 12 outcomes. To calculate the actual what each outcome is, I suggest you use a highlighter, and I actually use that, and start from the beginning, and I want you to highlight every part. So that is black pants, white shirt, and sandals. That's my first event. So let's just write that in. I've got black pants, white shirt, and sandals. Then go back to the beginning. This has been highlighted. So I've still got my black pants, still got my white shirt, but I need to highlight my tackies. So my next event is actually, I'll find a pen, black pants, white shirt, and tackies. And you do that for every single one of the events until you've got all 12 of them written out. And that gives you your outcomes. So don't forget, go back to the beginning in every case. So let's just do one more example to see where we would go. Right, I've still got my black highlighted, but now I've got a blue shirt and sandals. And then I'll go back to the beginning. So black shirt, black pants, blue shirt, and tackies. Let's just write those 2 events in so we don't get confused. Right, it was black pants, blue shirt, and sandals, black pants, blue shirt, and tackies. And you can do that for all 12. Not going to go through it right now because I'm sure we're going to get to do one of these in our exam, in our questions. Right. The next way of calculating the possible outcomes is using a contingency table. This table is used to record the relationship between two or more categories, and it is usually set up in rows and in columns, with the rows indicating one category and the columns indicating the other. So this is an example of possible outcomes of throwing two dice. I'm going to highlight the first dice, which, remember, I said to you columns was one event and the rows were the other. So I'm going to assume that this is my first event. There's my first dice. I've got 6 possible outcomes for the first dice. It can be thrown either 1 to 6. And for the second dice, we're going to use this. I've got, again, 6 events. Then what the contingency table does in the middle is it actually gives me the outcomes of the 2 occurring at the same time. So let's go and highlight the first dice. In my first column, I've got possible 1. So if my first dice lands on a 1, my second dice still has the possibility of landing on a 1, 2, 3, 4, 5, or 6. So we end up with the 2 as 6 different possibilities. When we look at all the dice together and them landing on everything, we end up with 36 outcomes. Now, I've completed the entire table for you. You could do it on your own, I'm sure. So we've got 36 outcomes of this event occurring. Right, let's move on to the next part of our discussion. Now we're discussing the kind of events that occur. So we've got 2 different kinds of events that we discuss in Maths Lit. The first one is mutually exclusive events, when it's possible for an event to occur at the same time. In other words, the probability of one thing happening or the other does not affect the other. So either one can occur. For example, the dice landing on a 3 or a 6. So what's the probability of a dice landing on a 3 or a 6? In this case, we're going to add the probabilities. So let's just do this quick calculation. I'm going to do it over here. Right, so the probability of it landing on a 3 is 1 out of 6, because I've got only 1 3 on the dice and I've got 6 sides. And then the probability of it landing on a 6 is still 1 out of 6. But now these events can't occur at the same time. So I need to add them. It's either a 3 or a 6, and we end up with the fraction of 2 out of 6, which again you can simplify, but you don't have to. An independent event is occurred when one event does not affect the occurrence of the other event. The events are totally independent of each other. In this case, we multiply the probability of each event. And this, when you see this in your, let's look at the example, what is the probability of throwing a 6 on a die and, that's an important word, heads on a coin. So let's do the calculation. We've got the probability of throwing a 6 on a die is 1 out of 6. The probability of heads on a coin is 1 out of 2. We've only got 2 sides to a coin. And this and in probability, we multiply the 2. So it's important to remember, and I'm going to just make a note here, is basically you don't have to consider whether it's mutually exclusive or independent. You can see it in the wording of the question. Wherever it says and, we're going to multiply, and whenever it says or, we're going to add. And it seems to go against your natural instinct. Normally when you say and, you want to add them. So you've got to go against that, and remember, and is multiply. So let's carry on this calculation. You can use your calculator to do this. In fact, let's do that. So on your calculator, let's use a fraction button. So we're going to say the probability of a dice was 1 out of 6, and another fraction, the probability of the coin was 1 out of 2, and I end up with 1 out of 12. So I don't think we needed the calculator for that. We end up with an answer of 1 out of 12. If you want to do it in your heads, you're welcome to. Remember, when multiply, we multiply the top and multiply the bottom. So 1 times 1 is 1, and 6 times 2 is 12. Right, let's see what happens about replacing or not replacing a value. Now, this is another very important part of this calculations. When dealing with any probability, it is important to know whether once the first event has occurred, the item in the set is no longer part of the outcomes, or whether it has rejoined the set again. So let's look at an example. If a bag has 12 balls in it, made up of 4 red, 6 blue, and 2 green. If a red ball is drawn randomly and not replaced in the bag, the total number of balls becomes 11 before the next ball is randomly chosen. So let's look at the probability of choosing a red ball. So the probability of a red ball, I'll write it like that. Our probability was, how many red balls were there? There were 4 red balls. Out of a total possible 12 balls. Can leave the answer exactly like that. Now, if I had to choose, what's the probability of me choosing another red ball? But I have kept that red ball. I have not put it back into the bag. So probability of a red for a second time, I now have only 11 balls left in my bag. So my outcomes are only 11. And how many red balls have I got? Well, we always assume that we have taken out that one red ball, that we actually did get the red ball. So what is left is now 3 red balls out of a total possible 11 balls. So this is an important fact to remember. Your outcomes diminish by 1 if you're taking out a possible outcome, and as well as if you are choosing a red a second time, that you need to change the number of red balls. But if I was choosing for the second ball, say a green ball, that doesn't change. I've still only got 2 green balls. Let me see, there were 2 green balls. So that was 2 green balls, but I had out of 11 balls. So let's assume that that never occurred. Then I've got 2 out of 11. So just read the wording carefully and double check that you've got the correct answer. Right, let's go ahead and answer some questions. So question 1 says, express each of the following probabilities as a common fraction. You do not have to simplify the fraction, a decimal fraction, and a percentage. So for each one of these, we need to do 3 things. Right. A jar has 12 blue marbles, 21 red marbles, and 17 green marbles. What is the probability of selecting a red marble? So my probability is my event, my favorable event. My favorable event is my red marbles. So how many red marbles have I got? I've got 21 red marbles. Out of a total possible, now we need to add these up. You can use your calculator if you'd like. So let's just do that and double check. We had 12 and 21 and 17. So we had 50 marbles in total. So go back to here. Right, it was 21 out of 50. We don't have to simplify, and that is part 1 of our solution. So part 2 of our solution said a decimal fraction. Just want to double check the question before I carry on with the other 3 to check that I actually have answered the question correctly. So it said, what is the probability of selecting a red marble? I have done that. Now I need to put this into a decimal fraction. Well, clearly I need my calculator. So I'm going to use my calculator. I'm going to type in my fraction and press equals, and then press my SD button, and I get 0,42. So in this case, the answer is 0,42. And lastly, they want a percentage. A percentage, remember, whenever they ask you for a percentage, what do we have to do? We have to multiply by 100. So I know somewhere along the line I have to multiply by 100. And it's probably easiest if I use my decimal, but just in case I've made a mistake with this, I'm going to go back to my original 21 out of 50 times by 100, and I'm not sure if I need my calculator, but let's use it. So I've already got my decimal. I can times that by 100 and get the answer of 42. And remember that your 42 is a percentage. For the rest of the answers, you don't need to actually give us a unit. But as soon as we've got percentage, then I want a unit. Right, let's move on to the next question. Again, we need to do common fraction, decimal, and percentage. What is the probability of not selecting a red marble? Not selecting a red marble basically means selecting any other color than red. So, well, I can work that out as, let me go back to my question. Not selecting a red, well, then I would be selecting a blue or a green. And what I can actually do is I can add the blue and the green together, or I can add them here and say, well, okay, I've got 12 blue and 17 green, which gives me 29 that are not red. So let's go and do that. So my possible outcome is basically 29 out of a total possible 50. That hasn't changed. We're assuming that we have replaced the last marble that we put in. So that's part one of my solution. Part two is putting it into a decimal. So we're going to do that on the calculator. That's not that button. Add 29 out of 50. And I get an answer of 0,58. So type that in. And the third one was the percentage, so times by 100, and I can use my 29 out of 50, or 0,58, and I'm going to get 58%. I haven't gone back to my calculator because I now see that what I did before was just move my decimal place to 2 places. But use your calculator if you want. Use your calculator for everything if you have to. Let's see what the third part of the question is. What is the probability of selecting 2 red marbles without replacing the first marble selected? So I'm going to go back to what was the probability of selecting a red marble. A red marble was 21 out of 50. So now we want to select 2 red marbles. So my first was 21 out of 50. This is part one. My first marble was 21 out of 50. Now I am not replacing it, and I'm not replacing, but I need to choose a red and another red. So first let's work out the probability. So now I have 20 red marbles left. So remember I took one out, and I've got a total of 49 marbles left. And I want 2, so it has to be a red and a red, which means that I need to multiply my answer. And we definitely need to do that on the calculator. So I have a fraction. I've got 21 out of 50. And a second red of 20 out of 49. That's not how we write 49. And I always check my calculator that I'm actually completing it correctly, because I've just made a silly mistake. And if I wasn't checking, then I would have pressed equals, assumed that my answer was correct, and I would have been wrong. So it's always a good idea to check what you actually typed in onto your calculator. Right, let's press equals, and it gives me an answer of 6 out of 35. Your calculator is going to simplify it for you. I know the questions say don't simplify, but there's nothing wrong with that answer. So we're going to not make things more complicated, and we're going to type in that answer. So it was 6 out of 35. The second part was now a lot easier. Calculate that as a decimal. So go back to my calculator, and I just need to use that button, 0,171. I'm going to round to 2 decimal places. So let's type that in. 0,17 is my decimal. And finally, as a percentage, I'm going to 0,17 times by 100%. And this is what's nice about your calculators being able to keep all these percentages, all these decimal places. We have rounded it off in our notebook, but the calculator, I want you to keep that number for as long as possible, because all I'm going to do is times by 100, and I'm going to get an answer at 17.14%. Always round to 2 decimal places unless they tell you otherwise. So my probability here was 17.14%. Right, let's move on to question 2. So, a box of chocolates is randomly selected from a production line to check to see if any of the chocolates are faulty. Now, this occurs on a regular basis. So, we're going to check to see if the chocolates are faulty. Each box contains 12 soft-scented and 8 hard-scented chocolates. 2 chocolates are randomly selected from the box and are tested to see if they have any faults. So we're taking our box of 12 and we're going to randomly just select 2 out of that box to see if they are faulty. First part of the question says, draw a tree diagram to show all the outcomes indicating the probability on the branches of the tree. So first we need to draw our tree diagram and we need to show all the possible outcomes. So how many events have we got here? Remember, we've got 2 events occurring. We're taking out 1 chocolate and then we're taking out a second chocolate. So we've got 2 events occurring. So let's find a little bit more space. And I'm going to start in the center of the page. So for my first event, and we always draw the first event. Well, we start with the first event. We always draw all the outcomes for the first event. Right, I've got a soft-scented chocolate or a hard-scented chocolate. That's my first event. Now I'm going to complete my second event. So, and each branch that we have on the tree diagram needs to have the second event occurring. So if I chose a soft-scented, I still have 2 options for my second chocolate. It can be a soft center or a hard center. That's one branch. Now we've got our second branch. Well, we've got a soft center and a hard center. Now I have all my possible outcomes for these events occurring. So I've got 1, 2, 3, and 4. So we count all the final branches and it'll tell us how many outcomes we've got. Before I carry on with the calculations, I'm going to actually write out all my outcomes that I have. So I'm going to use my colored pen like I told you to, and write out all the outcomes. So I've got a soft center and a soft center. So we can type that in. So my first event is soft and soft. Go back to the beginning. Let's go back to our color. Go back to the beginning and highlight, make sure everything is highlighted. So I've got soft, and then my next one is hard. So I've now got, let's do that in green, soft and hard. That part of the tree is complete. I can see it's all highlighted, so I'll move on to the next. So I've got a hard sweet, and let me start with my first line, soft. So write that one in. So that I've got hard and soft. And finally, let's just extend this a little bit. Go back to the beginning. So I'll go hard and hard. So my last outcome is hard and hard. So those are my 4 outcomes that I have. I can have 2 soft-scented sweets, 2 hard-scented sweet, and 2 sweets that are both soft and hard. So 1 soft, 1 hard. you can see that these outcomes are actually the same. But be careful of outcomes that are the same if they ask you for a specific order. So if they ask you for the probability of first picking a hard and then a soft, then it is actually only 1 out of a total possible 4. But if they ask you for the possibility of choosing 1 hard and 1 soft, well, now the probability is 2 out of your possible 4 outcomes. Let's go back to the question, because the question said draw the tree diagram to show all the outcomes, and it said indicating the probability on the branches of the tree. Now, we haven't done this before, so let's work out our probability of each thing occurring. So what is the probability of me choosing a soft center? So the probability of it being soft is my total favorable outcome. What do I want? I want the soft, so there were 12 soft. Out of a total possible, how many chocolates do we have? 20. So that's the probability of a soft scented sweet occurring. And the probability of a hard is now, how many hard did we have? We've got 8 hard out of a total possible 20. So those are my probabilities. Now what the question wants us to do is they want us to indicate those probabilities on the branches. So what I'm going to do is, for each branch, this branch was a soft branch. So my soft was 12 out of 20. For each, and then my hard branch was 8 out of 20. So I've got my first outcome, but I still have further outcomes occurring. So I need to do this for everyone. This was a soft outcome, so that's 12 out of 20. A hard was 8 out of 20. Soft was 12 out of 20. And hard was 8 out of 20. Now I've got all the outcomes that they wanted, and if I answered the question correctly, let's just reread it. Draw a tree diagram to show all the outcomes, indicating the probabilities on the branches of the tree. I have my tree diagram drawn, I've got all my outcomes, and I've got all my probabilities on the branches. I'm sure we're going to use that to answer the next part of the question. Calculate the probability of selecting 2 soft scented chocolates. Now remember, if we're selecting 2 chocolates, well, we're going to be adding, we're going to be selecting a soft center and another soft center. So we're going to be adding them, but let's go to our tree. Well, our probability of our outcomes was 1 out of 4. But we have different probabilities of this occurring. So we need to use our probability that we have filled into the branches to actually do this calculation. So I'm going to say, well, it is this and it is that. Right, now that we've completed our first event, we need to go on to the second event. Now this is a little bit more complicated because now we've got 1 chocolate missing. So our probability of these things occurring is actually out of 19. And we need to bear in mind that if we've taken out a soft scented, we've already taken one of those. So let's just do a little bit of calculations here. Let's extend this board a little bit. So my first was a soft, and my probability was my soft. I'm just going to rewrite that again. So I had that as 12 out of 20. Now if I want my probability of a soft occurring again, I've taken 1 soft out, so I've only got 11 left out of a total possible 19 chocolates left. And if I took out a soft in beginning, I now have my probability of a hard is still 8. There are still 8 hard chocolates left, but there are only 19 left in the box. So those are the outcomes that I'm going to place into this top part of the branch, because that was if my first outcome was a soft chocolate. So my soft chocolate now is 11 out of 19, and my hard was 8 out of 19. I keep wanting to write 20. 8 out of 19. Let's do the second part of this branch. Well, now I'm going to assume that I've taken out a hard chocolate, so let's do that. So if my first was a hard, which I'm just rewriting this as 8 out of 20. Now my probability of it being soft, I haven't taken out any soft chocolates yet, so I still have 12 soft chocolates, but out of a total possible 19, or my probability of a hard, so I'm now assuming I've taken out that hard chocolate, so I have 7 hard chocolates left out of a total possible 19. So let's go and write that into our table. So the soft was 12 out of 19, and my hard was now 7 out of 19. So you remember your probabilities actually change as one event occurs, because in this case we took out the chocolate and kept it out. When we did our calculations to work out how many outcomes there were, we saw that there were 4 outcomes, but these outcomes are very much dependent on the probability of each event occurring, which are different. So we can only count this as our total possible outcomes of 4 when we're dealing with something that has got an equal chance of happening. Right, let's now go see what our question says. So the next part of the question says, calculate the probability of selecting 2 soft-scented chocolates. So let's go back to our table, and we're going to read that off the table, and I'm going to use a different pen to try and highlight that for you. So 2 soft-scented, I need a soft and soft, which means I'm dealing with this top branch. So I'm dealing with that probability and that probability occurring. So 2 events, I want a soft and a soft, so I'm going to multiply these 2 events. So let's go and write that in. So my probability was the probability of 2 soft-scented, let's make it like that, is now the first event was 12 out of 20 that we got from our branch of our tree, and the second event was now 11 out of 19. And now we're going to need a calculator to work that out. So let's use our calculator. Fraction button, we've got 12 out of a total possible 20, and we've got another fraction of 11 out of 19. So our answer is 33 out of 95. Remember, your calculator is going to simplify this answer for you, and that's a perfectly acceptable answer. So 33 out of 95. Now, just going back and rereading the question, it says calculate the probability of selecting 2 soft-scented chocolates. It did not tell me how they want the probability to be calculated, whether it was a fraction or a decimal or a percentage. So in this case, any one of those 3 is a valid answer, and any one of those 3 will give you the marks. So rather leave it as a fraction than trying to do more, and sometimes we tend to make those like little silly mistakes. So leave it as a fraction. You don't have to worry about converting it or changing it or anything to that effect. Let's move on to the next part of the question. Right. Now it says calculate the probability of selecting a soft-scented and a hard-scented chocolate, and not in any particular order. So I want to go back to my tree diagram. Okay. And now I'm looking for soft, scented and hard, and it could have been in any order. So I'm looking for these 2 branches of the tree. So I'm going to calculate the probability of either one of those occurring, and they can't both occur. So it's going to be soft and hard, or hard and soft. I'm going to go through to those numbers and reread the question so we can see what I'm talking about in the ands and the ors, and to pick up those keywords. So the probability of selecting a soft-scented and hard-scented chocolate, not in any particular order. So my probability was actually soft and hard, or it could have been, so let's change that to soft and hard, or it could have been hard and soft. So I can't choose both of those events, because then I would be choosing 4 chocolates. So That is what it means by any particular order. So now let's go through and see what were those probabilities. So going back to my table, I can see that my first event was 12 out of 20 and 8 out of 19. So let's go through and write that in. So the first was, for soft, was 12 out of 20, and my hard was 8 out of 19, or the probability of hard, I'm just going to go back and check what that was. Hard was 8 out of 20, and then soft was 12 out of 19. So now we can write those in. So, and it was 8 out of 20, or, sorry, and, getting myself confused here, 12 out of 19. So we can calculate that. That is the probability that they're looking for, and we can calculate it all in one step. You can do one first and then the other if you'd like, but your calculators can do it all together. So let's just use the calculator, right? So my first was 12 out of 20. In fact, I'm going to show you both ways. So let's work out the first probability, and that was 8 out of 19. And I get an answer of 24 out of 95. So let's type that in, 24 out of 95. And let's do the other one and clear that. So I've got 8 out of 20 and 12. Need a fraction. Remember, checking what you're typing, always a good idea. Out of 19. And I get 24 out of 95. Do we expect it to be the same? Are we expecting our answers to be the same? Well, I definitely am, because I don't think it makes a difference whether you choose the soft first or the hard first, but it's either or. I am expecting these probabilities to be the same. So I'm glad that they have come out the same. So now let's add the two together. So I have one already. I can just press a plus and another 24 over 95. And I show you an answer of 48 out of 95. So that was my answer. It's 48 out of 95. And that's my probability of choosing soft and hard. Let me just show you on the calculator how we would do it in one step. And our calculators are wonderful. They do this all for us. So times by 8 out of 19. And then we added 8 out of 20, or the 12 out of 19, and our calculator does it all for us and gives us our answer of 48 out of 95. So your calculator is wonderful, and it can do it all. But what I want you to note is, please don't just give me an answer. Even if you've just put it straight into your calculator, substitute it into your calculator, and got an answer, I want you to get into the habit of actually showing all calculations and everything that you're doing. So show me what you're going to be putting into the calculator before you just give me an answer. Problem with just giving an answer is that if your answer is incorrect, you're going to lose all your marks. If you have shown all the calculations and shown all the working, you will probably get method marks for continuing. So let's assume I'd made a mistake somewhere in this part of the exercise. Say I made a mistake here, and therefore this answer was wrong, and therefore my final answer was wrong. But I will not lose all 3 marks. I probably will only lose 1 mark for making that mistake. If I only give an answer and the answer is not the same as the memo, you're going to lose all your marks. So it's very, very important for you to show calculations every step of the way. You've got to make sure that your examiner or your teacher actually knows what you're thinking. And if they know what you're thinking, then they can calculate what you've done and work out the mistakes you've made, and you end up with method marks. Right, let's move on to the next question. Right, question 3. says a survey was done at the local shopping mall to determine how many males and how many females actually enjoyed shopping. And it's quite an interesting little survey, and I'm sure my husband would have been absolutely hated shopping, and my daughter too. We're going to use the contingency table below of the survey results to answer the following questions. Before we move on to the questions, I'm going to analyze this contingency table. Contingency table looks very different to the one that I showed you earlier with the two sets of dice. So we're going to just analyze this, and we're looking at a few different things. We're looking at, along here, we've got, let's highlight this, we've got gender. So whether they're males or females, and then I've got a total. Across my other axes, where have I lost my pen? Okay, there it is. I have whether they enjoyed shopping or did not enjoy shopping, and again I've got a total. So let's look at each one of these categories. We're now reading basically my green going that way and my red going this way. So these people over here, maybe I shouldn't use that color. Right, let's try it with pink. These people over here fall into enjoyed shopping and males. So there were 115 males who enjoyed shopping. And each one of our rows, each one of our columns and rows, each one of our blocks actually represents two things. These represent enjoyed shopping, did not enjoy shopping, males and females. So if I look at this over here, I've got did not enjoy shopping and females. Does it make sense how we read the contingency table? And then we've got our totals. The totals that enjoyed shopping, the total that did not enjoy shopping, and finally, the total number of people that were surveyed. So we're dealing with possible outcome of 800. Now we need to read the questions carefully to see what kind of question, what kind of information they want. So if we select someone at random, that someone at random is basically someone out of our sample of 800 people. That's what we mean by somebody at random. So it's not somebody else, it is somebody that we have actually surveyed. So if I select someone at random, what is the probability that they will be female? So let's find us some place. We're looking for female and we're looking for somebody at random. So my possible outcomes were 800. That random person has to come out of my outcome pool of there were 800 people. What is the probability that they will be female? Well, now I need to find my females. And for my females, I see, well, I've got 372, I've got 101. So we're looking at 473 females in total. So my probability is 473 out of 800. Remember I said to you, you can leave it exactly like that. Please be aware when you're answering these questions, very, very often, and it seems like it hasn't occurred so far in the questions we've asked, very often they ask you for something that is impossible to occur. So there might be a question that says, well, what is the probability that it was a cat that was surveyed? Just a random argument's sake. It does not occur. And very often your answer is going to be 0. They're going to give you a question where there is no chance that it did occur. So look out for those. Right, and also look out for ones where you've got 100% chance. So for example, they might say, what is the probability if I chose somebody at random that they were surveyed? Well, that would be 800 people were surveyed out of 800 people, and it would be 100% chance of that occurring. Let's move on to our next part of this question. If we selected someone at random, what is the probability that they will be male who does not enjoy shopping? So again, my probability is out of my total possible 800. So that is my total outcome. I'm looking for now a male who does not enjoy shopping. So I'm going to look at the males. I've got that did enjoy shopping, and these did not enjoy shopping. So it is my 212 males, not my total. I'm looking for very specific males who did not enjoy shopping. So my probability here is 212 out of 800. Leave it exactly like that. The next part of the question says, if 70 people were selected from the sample, how many of them could we expect to be females who do not enjoy shopping? Now what they're telling me is that we had our 800 people, and out of these I'm going to select 70 people at random. Of these 70, I want to know how many of these are actually female who did not enjoy shopping. So out of my 800, I am now limiting it to 70 people, but I'm still dealing with the same probabilities. So what I need to do to answer this type of question is I need to find out what is the probability of me first choosing a female who did not enjoy shopping. Now that's the first step. So let's work that out. So the probability of being female who did not enjoy shopping is out of my total 800. I'm looking for my females who did not enjoy shopping, and I'm looking at that answer there. So it is 101, I'm going the wrong way, 101 females who did not enjoy shopping out of the total possible 800. Now it's going to be easier for me to work this out as a percentage because it's easier for me to multiply percentages. So what I'm going to do is I'm going to convert this to a percent. So let's work out of the total 800 people, and we're going to do this on our calculator, I've got 101 females who did not enjoy shopping out of my total 800, and I'm going to times that by percentage, and I'm going to get an answer of 12.625%. And I'm not rounding off until the very last step of my calculation, not rounding off anything. So my probability here was 12.625%. Just want to double check that I actually wrote that correctly. 12.625%. That is the probability out of my total 800 of me having a female who did not enjoy shopping. Now I'm going to look at these 70. So if I chose 70 of those people, what I'm expecting is out of the 70 people, 12.625% of them will not enjoy shopping and will be female. So I'm going to take the percentage that I calculated for my total and now apply it to my smaller sample. So, and this is the reason I changed it to a percentage. It makes it easier for me to calculate a percentage of a number. So I have 70 people and I'm going to times it by 12.625%. So on my calculator, let's do that. I've got 70 people times by 12.625%. And this is the reason I did not round off. I could have rounded off to 12.63, and you're probably not going to lose marks in an exam for rounding before the last part of the question. But my 12.625 just makes it that little bit more accurate. So let's actually do the two calculations just to see how our accuracy changes. So 12.625%, I'm going to press it as equals. Right, I'm dealing with 8.8375 people. Okay, I need a pen. 8.8375 people. I can't really deal with an 8.835 people, so in this case I'm going to make it, well, I'm expecting 9 people to be female that don't enjoy shopping. Let's just look at our calculation. If we had changed this to, let's go back here, and change that to a 3 and see what difference it makes, it would have made it 8,84. Well, in this case, it wouldn't have made a huge difference because we did need to round up to 9 people. But if you're doing another calculation, it might have an effect. So rather get into the habit of rounding off only at the very, very end of your sum. Your calculator can keep all those decimals, so you don't have to worry about it. So my answer now, I've got 9 people. Let's go back and check that we have actually answered the question correctly. If 70 people were selected from the sample, how many of them could we expect to be females who do not enjoy shopping? I have actually answered the question because I've taken my entire sample, worked out the percentage of females who did not enjoy shopping, then applied it to my 70, and now I'm expecting that 9 out of those 70 people were female who did not enjoy shopping. Right, let's move on to our next question, question 4. So let's read the question first. So, Christian goes off to a fun fair with his buddies, Stefan and Eduardo. There they find a game where they can make 500 Rand quickly. So let's see, they can make 500 Rand quickly. The game is as follows. There's a circular dartboard that's divided into segments as shown in the diagram below. So let's look at our diagram and see what we've got. Well, we've got our circle of our dartboard and it is divided into 3 different colors. Go back to the question to read. The color white makes up 30% of the board, so that was your 30%. The black makes up 20%, so I've got 20% of black. And finally, we've got gray that makes up 50% of the board. The board is spun around on a pivot point so that there's no way the boys can aim for a specific color. So the board is spun, they've got a dart, and they need to throw the dart onto the board. The boys each get a dart to throw at the board. Christian has the first throw, Stefan the second, and Eduardo throws his dart last. In order to win 500 Rand, the 3 darts must hit the following colors in any order. So the colors are white and gray, and then black or gray. So each one of the boys has got a chance. So Christian, and it can happen in any order. So Christian can hit the white, or he can hit the gray, or he can hit the black or the gray. But then as soon as he has hit once, let's assume he has hit the white, then the next 2 boys, when they choose, must not hit the white. It can be gray or black and gray, and as soon as that's out of the question, then we need the last one to hit black or gray. So we need to calculate our probabilities. What is the probability that the boys are going to win 500 Rand? So we need to go through this very carefully. We need to work out the probabilities first, and then we're going to work out what the probabilities of all these events occurring. So let's work out the probability of us hitting a white. So the probability of white is basically, go back to my table, to my dartboard, and my probability of hitting white is 30%. So I'm going to say probability of white is 30%. I'm going to actually write it as a fraction because I think it's easier to calculate when we've got it as fractions. So the probability of white is 30 out of a total possible 100 because it's a percentage. The next one that we needed was gray. So we're now dealing with gray. So the probability of it being gray is, go back to my board, gray was 50%. Or I'm going to make it 50 out of 100. I can simplify, but you know what, my calculator can work with these big fractions, so I'm going to leave the fractions as is. The last one needs to hit black or gray. So let's extend this. I need the probability of black or is a plus. Don't forget that, or gray. So my probability of black, let's go find out what that was. Probability of black was 20%. So that was 20%, or 20 out of 100. and, it's not and, or the probability of grey, and we've already calculated that as 50 out of 100. So my total for this is I can add them up, and I can use my calculator to do that if you need. So it was 20 out of 100, or it was 50 out of 100, and 7 out of 10. I'm going to use that as 70 out of 100. So go back to my writing. So I'm going to say that that was 70 out of 100, or 7 out of 10. So maybe in fact we can simplify all of these to 7 out of 10. Let's make that 5 out of 10 and make that 3 out of 10. So all I'm doing is basically eliminating just one decimal place. Now I've got all my probabilities calculated, but this doesn't give me my probability of them winning the 500 Rand. So we need to go back to the question to see what was that. They needed to throw the dice in the following in any order. So we needed it to be white and grey and black or grey. So I've got each one of these calculated. So what I'm doing is I'm saying probability of white, and so I'm going to multiply the probability of a grey and the probability of, left out my probability, of black or grey. So because I've calculated these probabilities already, all I'm basically doing now is substituting in my values. So the probability of white occurring was 3 out of 10. And the probability of grey was 5 out of 10. And the probability of black or grey was 7 out of 10. And now I can use my calculator to get me an answer for that. So what is the probability of them winning? It was the probability of white and the probability of grey and the probability of either black or grey. And I get an answer of 21 out of 200. So I'm going to write that answer in. So my probability is 21 out of 200. That kind of, I know I've got the right answer, I know I've done the calculations, but it doesn't tell me much in everyday terms of what are the probabilities that they're going to win. I've answered the question, but does it make sense? Not really. I don't know how much 21 out of 200 is. That's what I mean by does it make sense. I don't know what that answer gives me. And I really always like to make sense of the answer and make sure I understand what that actually means. So rather than working in this fraction that doesn't make any sense to me, I'm going to work as a percentage. Percentage I can comprehend. I can understand what the percentage is and how much the chances of them winning are. So I'm going to go back to my calculator, and I've already got my answer in there. So I'm going to times by 100 and see what that gives me in a percent. 10,5% chance of them winning. So let's write that answer in. So it was a 10,5% chance of winning. There was a 10.5% chance of them winning 500 Rand. So I don't think that's as easy money as they think. I think it's a lot harder, 10.5%. That basically means, if we look at that calculation, and I'm just going to take that and minus 100%, and I'm going to get 89.5%. Let's just write that in. We can just discuss the chance of them winning. So I've got, if I took my 100 minus my 10.5%, make that 100%, I've got an 89.5% of not winning. And often when we deal with probability, it's always good, it's often good for us to look at the reverse. So they've got like nearly a 90% chance of not winning. There's a 10% chance of them winning. Should they take the chance and try for the game? Well, I think for 10% of the chance, if they don't try, they can't win. There's no probability of them if they don't try. I think that it probably would be fun for them to try. So maybe they should take the chance, but the chance of them actually winning is not that huge. And it's often interesting to look at the chance of not winning in comparison. And that's what we've done. So now let's see if we've checked, have we actually answered the question? Go back and check. And remember, I keep telling you, go back and reread the question. Make sure you have answered exactly what they are asking you. So I'm going to read this from the beginning. So it tells me about the board, okay? Then in order for them to win 500, there are 3 darts. They must hit the following colors in any order. So white and gray and black or gray. So what is the probability that the boys are going to win 500 Rand? Well, the probability we have calculated is 10.5% chance that they will win the 500 Rand. Hey, that takes us to the end of our questions that we've got set out for today. So I'm going to just quickly take you through the homework and give you a couple of other hints that I want you to remember along the way. So going through your homework, what I want you to do is I want you to work through this very methodically. Don't forget to show all your calculations. Remember, you've got method marks for everything that you do, and often you get marks for something that is wrong. If you've made a mistake in the first step, then it is important to have method marks. Look out for, before we go on, I actually want to go back and do one more example here. Let's find some blank paper. I want you to look out for those 0% chance of happening. So I'm just going to give you one more quick example. So to show you what I mean with this. So let's use screen. So just a last example. Let's just say I had 13 female, let's whatever to my pen, 13 female band members. So there were 13 members of a band, and of those 5 played the violin, and 1 was on the drums, and that's all the information that we were given. Now, if I ask you for the probability that they were female, well, we end up with the total favorable outcome. There were 13 females out of the total possible 13 band members, and I can see that that is 1 or 100% chance that they are females. What is the probability that they play the violin? Well, in this case, I've got my favorable outcomes. There were 5 that play the violin out of my total possible 13. And the last one I want to look at is, what is the probability that they play the piano? The question told us that there were 13 female band members, 5 played the violin, 1 played the drum. It didn't tell us anything about the other 7 band members, so we can't assume what instrument they played. So when we're looking for a question where it gives us the probability of a piano, well, we've got to say there were actually no piano players out of a total possible 13 band members. So in this case, our probability is actually 0. You can write it as 0%. You can write in the word 0, but there is no chance of me choosing a piano playing female out of this question or the information that I have been given. So look out for those questions where there's a 0 chance of it happening or 100% chance of happening. And remember that anything in between is between 0 and 1, as we discussed earlier. Okay, let's go back to our questions. So for homework, the probability that event A will occur is 0,2, and the probability that event B will occur is 0,6. The probability that both A and B will occur is 0,12. So they've given you all these numbers, and then they ask you, are events A and B independent of each other? And explain your answer. So remember, we needed to either add or multiply, and if they are independent of each other, we always said independent was multiply. So do the calculations, work out the probability of both occurring, and see if you get that answer. Show all your workings. Right, let's move on to the next question. The next question gives you a contingency table. So we're dealing with, the study was done between the airing of particular TV programs. 150 men and 100 women took part in the survey. What did they look at? Don't forget, analyze the tables carefully. So we're looking at 150 men, 100 women, and we're looking at, did they enjoy the program? I'm going to use my highlighters. So we're looking at our men and our women, that's our gender. Remember the other one, we had our gender on the side, but that doesn't matter where they are. And now we're looking at, did they enjoy the program or did they not enjoy the program? So your questions are going to be related to that. Calculate the unknown values 1, 2, 3, and 4 in the table. You're going to have to base that on, remember contingency table, everything adds up. So for 1, you're going to say, well, my men and my women is equal to my total. Okay, let's get back to our pen. My men and my woman is equal to my total, so you can easily calculate 1 and the rest of them pretty much the same way. Is a person's preference for a program dependent on gender? Use relevant calculations to support your answer. Whenever they ask you a question like this, which is based on probabilities, you're going to work out the probability of them enjoying the program, and I would suggest that you convert it to a percentage. Because if we need to compare two values, so we're going to basically compare the females to the males and look at a percentage, it's easier to compare, and then decide whether it was related to gender. So always use percentage. What is the probability that a person chosen at random enjoyed the program? Well, now you go up to your contingency table and use the values of they did enjoy the program and show all your calculations. The next question. Patience has just got her driver's license. She wants to buy a motor car and has narrowed down her options to the following. She's got the model, she can have a VW Polo or a Toyota Yaris. The type of car, she can get a sedan or a hatchback. And the color, she can have white, black, or red. So she's got 3 different outcomes, and in each outcome there are different criteria. So we're going to be looking at model, type, and color. Draw a tree diagram to show all the possible combinations that she has for her car. I want you to look at each event separately in this case. So you're going to first look at the model, and you're going to draw the branches of the tree. Then you're going to look at the type of car, and you're going to draw the branches, and don't forget to draw the branches for every single branch that has occurred. And then finally, your last one is going to be color. And then you're going to look at the 3 different colors. And again, don't forget that you need every single branch accounted for. So I suggest that you do this on a new piece of paper and start in the middle of the page so that you've got space and that you don't squish it all together, so that it's actually easy for you to interpret after you have done the calculations. Right, so that's a question. Now it says, Patience does not have any preference and there's an equal probability that she will choose any of the options above. So basically what we're saying is that there is no preference. So between the 2 cars, there's a 50% chance of her choosing either one of those cars. So it's an equal likelihood of each event occurring. What is the probability that she will choose a red car? We'll go back to your tree diagram, and basically you can count how many times you've seen a red car in your tree diagram and take that out of your total possible outcomes of the tree diagram. So this question, because there is an equal probability of something occurring, is different to the one we did with the chocolates. The chocolates, there was not an equal, and we needed to account for all those calculations along the way. But if you've got an equal likelihood of it occurring, then your outcomes stand as every outcome that you've calculated is equally likely of occurring. So all you need to do again, count the red out of the total possible. What is the probability that she will choose a VW Polo hatchback? So again, go through your calculations, go through your outcomes, and when you draw your tree diagram, you must actually fill in all the outcomes, and then you can actually go through and count the VW Polo hatchback and see how many times that occurs. And then it'll be out of your total possible outcomes. Right, so that takes us to the end of the session. I wish you luck with the homework, and I want to see every single calculation. So, and all your steps as you do your calculations, show the examiner exactly what you are thinking. Just a quick recap of the probability and the session today. Right, when working out the probability, remember we've got from a 0% chance of something occurring to a 100% chance of it occurring. It can be written in three ways. We can have it as a fraction, as a decimal, or as a percentage. Remember that when we're calculating our probability, it is always a favorable outcome out of our total possible outcome. So our calculation is just purely a fraction, which we can then make into a percentage or a decimal. Remember to look out for things like 0% occurring or 100% chance of it occurring. Something can't occur more than 100%. So be careful and be aware that if you get an answer of more than 100%, you have probably made a mistake. Remember to look out for things like, are you replacing the item or are you eliminating the item? So that's very important for our second occurrence, whether something has been put back into the mix or if it has remained out of the mix. Your ways of calculating your outcomes, remember you've got your tree diagram and each branch is an occurrence or an event, and don't forget to add to every single branch, you add the next part of the event. Or you can use a contingency table, which makes it easier for you to calculate the total possible outcomes. And you've got your one event occurring on the columns, one event occurring on the rows. So in total, you get your total possible outcomes. So just work through this carefully. And remember that calculation that I gave us, remember when we took out a sample of the outcomes, that it's easier to work in percentage. So we work out a percentage when we did that 70 people, when we were looking at the females who did not enjoy shopping. Remember, if we're dealing with a part of the sample, that you use your percentage and then multiply the probability by that part of the sample. And shouldn't be too hard for you to follow all these exercises, and good luck for doing it in the future. Thank you very much.